Hi, seventh graders, it's Mrs. Parati. This video is for your 7.1.3 lesson, and I'm including a homework help question in here just to see if I can get you to watch more of my lesson videos because you guys aren't watching any of them. And it frustrates me, but I still love you guys. So we're gonna look at two problems for this lesson. One where you are increasing an amount by a certain percent, and one where you are decreasing an amount by a certain percent. And of all the things that we've been talking about recently, this is something that I have used in my own life a whole bunch because we're talking about things like discounts, sales, or percent increases, like if you're getting a raise. So these are things that are totally out there in the real world. So it's important that you know how to find these answers. So the first problem that we're going to be looking at is 7-27, and this is going to be a model of a percent discount. So as you can see in the picture, Hugo and his family are looking at purchasing a new bed, and it is 60% off. So that means that it's a sale price. Okay, so the first thing that we're going to do is draw a diagram for this situation so that we can see what we're actually solving for. So in your notebook, I would like you to draw this along with me. Again, this is for problem 7-27. And we're just going to do a simple line diagram to show how much they're going to be paying for this new bed. So obviously we're talking about percents. So that's why I labeled 0 and 100%, because those are our two extremes. We know right now that the cost of the bed is $245 originally. So that $245 is going to be our 100% cost. And then we see that the bed was on sale for 60% off. So I'm just going to do a simple line here and say that this amount is 60%. Okay, so we know that Hugo is now paying for the bed at this cost, but we don't know what that cost is just yet. Okay, so there's a couple things that you can see right off the bat. Okay, so one of them being 100% minus 60% means that he's paying 40% for the bed. It's actually a pretty good deal. So now we just need to figure out what that is cost-wise. Okay, so let's look at part B. It says if Hugo scales or multiplies the original price of the bed by 60%, what will his result represent? So looking at this a little closer, if he's sitting here calculating like we did in the previous lesson where we were multiplying by a percent, you might think, or he is thinking, that he's taking the cost of the bed to $245 and multiplying that by a percent, which is 60%. Okay, so that's the original thought. I'm going to give you a tip here. Okay. When you are multiplying by a percent, it is way easier to multiply it using the decimal version. So instead of writing it like 245 times 60%, I did 245 times 0.60. Okay, so writing that percent as a decimal. Super easy to enter it into a calculator that way. When you do this, it gives you an answer of $147. Okay, but thinking about this, this $147 isn't what Hugo is paying for the bed. This $147 is representing that 60% amount. So this is actually the amount taken off the price, or the amount discounted. So that's not the actual amount that he's paying, okay? So in part C, we're going to talk about what Hugo should be multiplying by to find the new price of the bed. Well, if he wants to see how much he's paying, he's not going to multiply by 60%. He's going to want to multiply by 40% because that is the amount that he's actually paying for the bed. So we would do 245 times the decimal version, 0.40, and this is $98. Okay, so that's our answer for 7-27. If we were to write this a couple different ways, we could write it as 245 times 0.40. We could also write it as 245 times 40 over 100 if you want to solve it the fraction way. So, sorry, my cat is going crazy right now. I wonder if you guys can see this. Oh, he walked away. Never mind. So those are a couple different ways that we can write out this problem. So this is showing a percent discount. Okay, my cat's back. Hold on. See if you can see this. This is Henry, and he is very playful. Okay, so that's for a percent discount. Now I'm going to show you guys what we do with a percent increase. Okay, so now we're going to look at problem 7-28. And this is just doing the same kind of process, but a little bit different because we're not taking off anything from the price. We are adding to it. So looking at this one, Hugo's older sister, Sandra, had the same summer job for the past 2 years, blah, 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 blah. Last year, she worked and was paid a salary of $3,000. This summer, she's going to get a 6% pay increase. So let's draw the diagram out and fill in what we can. So this is for 7-28. There's our line diagram. This is showing 0%, 100%. And we know that she made $3,000, which is our 100%. Oops. Okay, but she's also getting a pay increase of 6%. So we need to figure out what amount she is getting in addition to what she's been paid for her summer job. Okay, so we did part A. We drew out the diagram. Now we're going to look at part B, which is, does it make sense that her scale factor or multiplier should be less than 1, equal to 1, or more than 1? So that means that if I'm trying to figure out what that missing amount is, am I going to, that was our diagram, am I going to multiply 3,000 by something that is less than 1, more than 1, or equal to 1? Well, since this is a percent increase, she's getting something more than what she was being paid. We are actually multiplying this by 106% because it's her same amount, 100%, plus the 6% that she's getting an increase of. So this would be more than 1, since our total is going to be larger than when we started. Okay, so part C, what is the scale factor below or between her original salary and her new salary? What number could she multiply her original salary by to get the new salary? Okay, so I kind of showed that already. She can multiply it by 106%, or if we wrote that as a decimal, 1.06. Okay, so that would give us a grand total of, I believe, $3,180. Okay, so you can also write this as a fraction. And I know that it seems weird to be multiplying it by something over 100, but remember that if we're multiplying it by 100%, it's the same kind of idea as multiplying it by 1, because we're multiplying it by itself essentially, or like we're not changing its value. But since it's 106%, that's accounting for the 6% increase that she had this summer. Okay, so this is percent increase. So we've now seen an example with percent increase and percent discount or decrease. For one of your homework problems, 7-33, you're going to be looking at a percent decrease problem or a discount or some kind of discount decrease type thing. And if we look at that homework problem really quick, it says the homeowner must reduce the use of his home's electricity. It usually consumes 25.7 kilowatt hours of electricity per day, and the homeowner has to reduce it by 20%. So find the amount of electricity. We have our diagram. This is 0%. This is 100%. That's always a good way to start with setting it up. And we know that 100% is what the homeowner is currently using, which is 25.7 kilowatt hours. And they need to reduce that amount by 20%. So that means that they need to use only 80% of what they are currently using. So what we need to do is figure out what that amount is. I believe that's what the question is asking. Find the amount of electricity that will be used after the reduction in 2 different ways. So basically you're finding 80% of the 25.7 kilowatt hours. So what you need to work out is 25.7 times 80%. And I already showed you some ways that you can calculate that out earlier in this video. So basically, to sum it all up, when you are having a sale or a discount or a percent decrease, anything that's less than 100% or you're taking away, you want to multiply that 100% amount by what you're actually going to be paying. So it's going to be an extra step if you're only finding like the 20% amount, because then you're going to have to do a subtraction, a whole bunch of stuff. So it's easier if you just say, okay, it's 20% off, so I'm going to find 80% of my total. When you have percent increase or a raise or anything where it's gaining an amount, you're going to multiply by 100% plus whatever it's increasing by. So your multiplier or your scale factor is going to be greater than 1. I hope that helps clear some things up. Your second homework problem is 34, which is a review of combining like terms. So that shouldn't be too bad. Email me if you have any questions, and I will see you guys later. Bye.